Good morning, boys and girls. My name is Miss Melissa, and I'm a fifth grade teacher at a local school called Corrales International School. Today, I'm going to teach you a little bit about the U.S. Census and actually a little bit more in depth about population change over time. So, what exactly is the U.S. Census? The U.S. Census is a count of all the people in a country, and it is carried out every 10 years. Actually, boys and girls, this is the year 2020, and we are going to get counted and are in the process of being counted right now. Can you guess when the last U.S. Census was, if it's every 10 years? That's right, it was in 2010, 10 years ago from today. There are actually two ways that you can participate in the U.S. Census. So the way I participated was I actually got my census through the mail, I filled it out, and I turned it back in through the mail. But there are other ways that you can fill it out too, such as electronically. Now, in our title, there is also the word population. Population is a big word, and what exactly does that mean? Population means the number of people in a certain area. It can be any type of area. For example, the population in my home is only 2 people. So, what we'll be doing today? Today, we will be learning about population growth and why it is important to use data in our thinking and within our decision making. Also, why is it important to see how population has decreased or increased over time? It's really important to get a count of people and to see if we are growing, because the government uses this information to finance or pay for things like our roads, our schools, our fire stations, and even our hospitals. So, this is a really cool map, boys and girls, and it is a little blurry, but I took this information here and I blew it up here, so I'm going to take some time to explain it. This map is called a heat map, and it represents our states and our population growth over 60 years. Those 60 years were actually 1890 to 1950. So, can you find where New Mexico is? Let me get my stick here. New Mexico is right here, and I'm going to explain some of to you the colors right now. So if you see a dark color, that means that the population growth was super huge. It was over 300%. If you see a light blue or a lighter blue color, the population growth was 170% to 299. An aqua color, right here, like Minnesota, 110% to 169. The lighter green color, such as South Dakota, 80% to 109. And the beige color, which is 13% to minus 79. So New Mexico, which is what we're going to be talking today, had a huge population growth. It grew over 300%. You might be wondering, well, that's really good to hear, but exactly how much did it grow? We're going to find that out too. Also, I wanted to point out that our neighboring states of Arizona and California also had a huge amount of growth, while Texas almost caught up to us. Now let's look at this one. This is almost the same type of map. We have here the same states and the same colors, however, our years are changed. We have here 1950 to 2010, only 10 years ago. Let's see how much New Mexico grew then. So New Mexico is again in a dark blue area. Dark blue stands for 175%. So again, New Mexico's population grew so much. Texas also grew as much. Arizona grew as much. California did as well. So now we're going to talk about exactly what those numbers were. Okay, so this is some data, and data is information with numbers in it. We have so many numbers here. We're going to be talking about 5 different states right now and in the next couple of slides. We have here New Mexico, Arizona. I'll use the flags here, boys and girls. This is a New Mexican flag, Arizona, Texas, California, and Colorado. The first set of information is 1890, and I'm going to explain a little bit here too. When I refer to rows, I'm talking about information that is across. When I'm talking about columns, I'm talking about information that is in a vertical form. So let's see how much New Mexico grew. New Mexico started with a population of 160,282 people. Then, 60 years later, in 1950, it grew about six times its size to 681,187 people. Now, in 2010, it expanded so much more to 2 million, over 2 million people with 2,059,179. That's so much. Let's see if we can compare and contrast it to another of our states, our neighboring states actually. My family is from Arizona, so I'm going to talk a little bit about Arizona. Arizona started with actually less population than New Mexico with 88,243 in 1890. Then it grew almost 10 times to 749,587 in 1950. And then it just has a gigantic population now to 6,392,17,000. So let's answer some questions now, boys and girls. What is New Mexico's latest population? Latest means the population that we have information for. Now we're going to get more information after this year's census, but our last census again was in 2010. So what do you think that was, boys and girls? We're going to look at the last column. And our answer should be 2,059,179. Let's see if we're correct. Yes, that's it. What did it start from? So what that means is what was the earliest population. So we go to our first column, and it's actually 160,282. Right here. Population-wise, and that's talking about how many people are in an area only. What is the biggest state of these 5 states? So we're going to look at this population and find the biggest number. So we've got 2 million, 6 million, 25 million, 37, and 5 million. It seems like California is the biggest state right over here with over 37 million people. So question 1. Did your state grow a lot, double or more, or just a little since 1890? We're going to be using the same information here. So here's New Mexico, 1890, with 160,000 to over 2 million. So I'd say yes, it did. What about other states? Why do you think that is? So if we look here, boys and girls, it seems like all of the states more than doubled. Why would that be? Well, it's because people migrated all over to the west from the east, but that's a whole nother lesson. So we have the same answers right here. Question 2, do you think the population of your state will increase or decrease in the 2020 census? So because it's been increasing, most likely it'll increase again. Since we grew at least 175% from 1950 to 2010, most likely it'll increase again. Question 3, using your prediction from question 2, how will this likely change the resources your state receives? Well, if we have some resources that are given to us now, we're going to have more. So most likely we'll have more resources for funding. And lastly, based on what you learned today, what would happen if people didn't answer the census questions or didn't count everyone in their home accurately? Most likely, people didn't answer the census or did not count everybody in their home. We would be lacking in some funding for schools, hospitals, roads, and our fire stations. So in summary, we learned about population growth. We learned that it's super duper important to be counted since our government decides how to finance our roads, schools, fire departments, and hospitals, among many other things using our census. Don't forget to get counted in the 2020 U.S. Census. I'm Ms. Melissa, and thank you for joining us today for APS Home, for At Home with APS. Bye.
Welcome, mathematicians, and thank you for joining us with At Home with APS. My name is Mrs. Sears, and pretty shortly I'm going to be joined by Mrs. Gaudette, and we're going to be working with you today on 3rd, 4th, and 5th grade math. We're really excited to work with you today. We have some really great activities, routines, a wonderful book and game at the end of this segment, and we're so excited to have you working with us. If you would, go ahead and get your math journal out or a piece of paper and a pencil. We're going to be finishing up the routine we started yesterday, which was the number of the day. And I would like you to go ahead and follow along with me. If you were able to complete it all together yesterday, then you may want to go ahead and check your answers against mine. But again, as I'm working, I'm just going to be doing my thinking and working out the problem in my way, so you can kind of see some different ways that you might approach the problem. All right, do you have that paper and pencil ready? So we'll go ahead and get started on our first routine. Our number of the day, if you remember from yesterday, let me go ahead and get a little pointer here, was 21,065. All right, so what happened with the way that we said that number? We didn't say the hundreds place. We didn't have anything in the hundreds place, so we therefore don't need to say that hundreds place when we're reading that number. The comma tells us it's 1,000, right? So when I say that 21 and I see that comma, I know to say 1,000, and then I read the rest at the very end, 21,065. If you remember, we were able to get to, yesterday, we were able to get to what was 1,000 more and 1,000 less. And we actually had some kind of great conversation actually around where it was at the 100. Yeah, do you remember that one? The 100 was quite difficult because in doing that 100, when we were at that 1,000, we had to think about what would be the 1,000 less than that because of that 0 in that hundreds place, right? Yeah, it made a real interesting problem for us to solve. All right, so 10,000 less from 21,065. What do you think I'm going to need to do? Which digit am I touching? Well, we were talking about this. This is where we're going to have to know we're going to be working with our, let me do that. We're going to be working with our digit that's in our 10,000s place. Okay, so if I'm thinking about a number that is 10,000 less, right now there's a digit of a 2 there, that would be a 20,000. What is 10,000 less than that 20,000? 10,000, right? So I'm going to need to put a 1 there. Do I change any of my other digits? No. That's going to be 11,065. All right. Now, same thing, 10,000 more. We had a 2 in that digit, in that space, in that place value. What are we going to need to do to that 2 or that 20,000 to make it 10,000 more? Add 10,000 more, right? So that's the 30. Do I change any of my other digits? No. It's just going to be that same 31,065. All right. That seems pretty cool. I'll give you a second to do that, and I'm going to go erase, and we're going to go to the next part of our routine. So you got those down? Perfect. I'm going to go ahead. I'm just going to do this. Get rid of the whole thing. We'll come back to it. Make sure I have this up here. All right, because you know Mrs. Sears sometimes has to talk herself through this. All right, our number of the day. So we know that's 21,065. Is this number odd or even? And how do you know? What tells us usually if a number is odd or even? Usually that very last digit. Our very last digit, as you know, is our 5, right? 5 ones. So a 5 is considered an odd number. So therefore, the whole number, 21,065, is going to be an odd number. But the way that's written, I'm going to have to make a statement, right? So this number is odd because, and we always want to explain our thinking, the last digit is odd. I got to really punctuate those dots on my eyes, huh? Those don't seem to want to do it. Same with that period at the end. So I want to make sure I'm doing this grammatically correct. All right, what do I need to do to round it to the nearest 100? The nearest 100, we really have to look at the digit in the tens place, right? Yes, because we're looking to see, is that number going to lean more towards a higher 100 or a lower 100, right? And that's determined by the digit that's in the tens place. So in this particular case, we're talking about 65. As a general rule, what do we round up to after which digit would we normally round up from? A 5, right? A 5. And seeing that a 6 is greater than the 5, we're probably going to round up to the 100, right? We're going to be rounding, because we have no hundreds in there right now. So our nearest 100 is going to be what number? And remember, the rest of those numbers afterwards will just remain those zeros. 21,100. All right. What about the nearest 1,000? Which digit do you think we're going to go to for that one? Yes, we're going to do the hundreds. I could hear you telling me that. We're going to do the hundreds, Mrs. Sears. All right, so look at our hundreds now. A 0. That makes it pretty easy for us, right? Yeah. We would have to get pretty close to that 5 to be able to round up. So in this case, we're actually rounding down for the nearest 1,000. What would be our nearest 1,000? 21,000. You guessed it. Perfect. Great job. All right. Now, I know we talked about yesterday, we wrote it in an expanded form, which was where we added the values of each of those digits and put them out all together. So when we're writing it in written form is just where we write out the actual words. So in this case, we have 21, hopefully I spell this right, 1,000. Would I put an and in here? No, because it's not a decimal. 65. That's the number that we have in written form. All right, one last step. We're going to double this number. Are you ready for this? What would you want to do with this if we're going to double the number? Well, we could double it by timesing it by 2, but actually I'm just going to stack it together like we're adding the same number together. So we have 21,000, let's see if I can get some space in here, 65 plus another 21,065. Let's see if we can remember some of our regrouping, because that's what's probably going to happen when we do our regrouping. Yeah. So what's going to happen with my 5s over here? I have 2 5s. What's 5 plus 5? 10. All right. Well, I cannot put the 10 in that space. It's only allowed one digit, right? So where do I put the 10 at? I've got to regroup that group of 10s and put it over the 10s column. All right. 6 plus 6. Is that really 6 plus 6? Yeah, thanks for catching me. It's 60 plus 60 plus another 10. So 60 plus 60 is 120 plus 10 more, 130. What are we going to put in there? We've got to put the digit that would have been in the tens place, which in this case, we actually have 13 tens. So we can't put that group of tens in there in that one digit. We've got to put the 3 and then regroup, you guessed it, that group of tens, which would be that 100, into the hundreds column. All right, this should be pretty easy. What's 100 plus 0 plus 0? 100. Great, and we have the space for that. What about 1,000 and 1,000? 2,000, and finally, 20,000 and 20,000. 40,000. All right, let's read this number when we double it. 42,000, I did that comma, 130. Wasn't that fun? Oh, I'm so excited about doing that. All right, let me go ahead. I'll give you a second to write that, but I'm going to go ahead and erase it. and then we'll forward this through. And I have another activity for you today. Hopefully that's not too blurry. I was thinking about this. But we have done this routine for you before, but I love that you could do this at home with any numbers that you have in your house or any numbers that you think of, even patterns that you can find there in your house. This is called Which One Doesn't Belong? So what we're doing here is I want you first to just I'm going to ask you a quick question. What do you notice about what's on that screen? What does it look like? Looks like it's multiplication, right? Yeah, I can see the multiplication symbol. I can see some form of equal groupings. I can see arrays arranged in different patterns and structures. I can also see repeated addition, okay? And I see that multiplication sign. So I'm kind of thinking this is talking about multiplication. What I would like you guys to do is I would like you to think about which one does it belong. It could be any of these squares in these boxes or sections. Which one doesn't belong and why? I have a couple for you, but I'd like to also hear your ideas first too. All right, so if I'm just looking at this very top corner, just a very surface thing that I noticed that's different is that this box, 2 times 8, has circles around all of the different arrays that are happening. No other box has circles on there.
All right, I have one. I have one. This one does not belong. Even though it equals 16, you're adding instead of multiplying.
I like that she said that about the whole thing that we might have noticed, because I did notice that it did have all of 16. All right, so try and see if you can figure out a few more that don't belong in there. And also, we've included in our resource, we've included some other problems for you to be able to figure out at home as well. So have fun trying to figure that out. I'm going to leave you there.
All right, everyone, we are moving into our problem-solving phase. Today, the work that we're going to be doing has to do with unlike denominators. I already hear it. Oh, Mrs. Gaudette, unlike denominators. Yes, I really do like them because I struggled with them as a kid. And this is something that now that once you get it, it's like, oh, why didn't I get that? So we're going to work through it and just keep trying. Don't have the oh and then give up. Just keep trying with me. So, of course, you can download this off of our website, and you can get this prior and try it all out on your own before I go over it. Or wait till I read through it, stop, pause me, and then go ahead, try it on your own. Then double check your work against mine. All right, we have this first one. All right. Oh, Alfredo. I couldn't read the name. I had to move it. Alfredo, yum, yum. Alfredo picked 2 3/4 pounds of peaches from the tree in his backyard. Wow. Whoa. I remember having a peach tree in my front yard, but I don't remember picking that much. He gave 1 1/4 pounds to his neighbor, Madeline. How many pounds of peaches does Alfredo have left? All right. The tool I always use, we circle any numbers we need to go ahead and solve this problem. What do we have? All right, 2 3/4, and then he gave 1 1/4. So I'm going to kind of do open circle there so we know. It looks like little ears, doesn't it? Open circle so we know that we have 1 1/4 pounds to his neighbor, Madeline. Now, what are we being asked to do? We know to always mostly look for the question marks. That's normally a clue to us. How many pounds of peaches does Alfredo have left? So I'm going to underline have left. Pounds is important because that is our unit. But for right now, I'm going to hold off on underlining that because really we're just looking at how much is left over. So what operation are we going to be using if it's left over? Are we going to add, subtract, multiply, divide? Yep, we're going to go ahead and subtract. So I have 2 3/4 subtracting 1 1/4. I didn't want to forget that. Okay. Oops, forgot my equals. All right, so you can do this in two ways. You can subtract the whole numbers first, or you can subtract the fractions first. I always subtract the fractions first. It's like when you do your subtraction and you look at your ones, then your tens, then your hundreds, because what if I needed to borrow? What if I needed to find some more there? So I'm going to use my fractions first. So 3/4 minus 1/4. Oh, whoa, look at that. They gave us a little clue. My denominator is fourths. Lucky for me, I didn't have to do any work on this one. So what is 3 subtract 1? 2. And then I do my whole numbers now. 2 minus 1 is 1. So the question to us was, how many pounds of peaches does Alfredo have left? So let's go ahead and put Alfredo, because we want to make sure whoever is looking at our work knows what I am answering. Alfredo has 1 2/4 pounds, and LBS, for all those people, and as a kid I never could figure this out, why is LBS the symbol for pounds? It is, and I'll have to research it, or you'll have to research, why is that the symbol for pounds? Alfredo has 1 2/4 pounds of peaches left over. All right. Did we answer our question? How many pounds of peaches does Alfredo have left? Did we answer it? Yep. So we can move on to the next question. All right. Dennis and Cody are building a castle out of plastic building blocks. They will need 2.5 buckets of blocks for the castle they have in mind. Dennis used to have 2 full buckets of blocks, but lost some and now has 1 3/4 buckets. Oh. Cody used to have 2 full buckets also, but now has 1 1/4 buckets. If Dennis and Cody combine their buckets of blocks, will they have enough to build their castle? All right, so the very first thing we got to do, we got to figure out what are some numbers that we need to solve this question. So Dennis and Cody are building a castle out of plastic building blocks. Do we need any information from that at all? Nope, we don't need that. It's just nice info to build us into the problem. They will need 2.5 buckets of blocks for the castle they have in mind. Is there any information we need there? Yeah, the 2.5. We need to know that is the total we have to have all together to be able to do this castle. Dennis used to have 2 full buckets of blocks, but lost some and now has 1 3/4 buckets. Is there any information we need there? I see, 2 full buckets, and then now has 1 3/4 buckets. So I should circle both of those. Wah, wah, wah. Yep. This is just extra information we don't need right now. It's nice to know what he used to have, but do we really need it? No. So we know he has 1 3/4, so we know we need that information. This was just misleading information to mess you up. You notice problem writers do that all the time to us. They're not very nice. Cody used to have 2 full buckets of blocks too, but now he has 1 1/4 buckets. So going back to this 2 full buckets, do we need that? Nope. They're just trying to confuse us. We do need the 1 1/4 buckets. If Dennis and Cody combine their buckets of blocks, will they have enough to build their castle? What are we being asked to do? Will they have enough? All right, so I have 3 numbers circled. What are the 2 numbers I need to work with first? Do I need the 2.5 to work with first? We could we could do that and then work with the other numbers. I personally try to do the least resistance when I do my math. So I personally am going to go ahead and use these two numbers. I have 1 3/4, and then I have 1 1/4. So what operation do we need to do to figure this out? Right, we need to add so that we can figure out how much Dennis and Cody have combined. So I'm going to go ahead and add that. And I like to add my fractions first. So I'm going to add 3/4 plus 1/4. So I know my denominator will be fourths. And then I add my numerators. 3 plus 1 is 4. Do you guys remember from a few weeks ago that we never, ever, ever add the denominator? Because that is telling us how many pieces are in the whole. So the pieces has no I'm jumbling up my words, but that right there does not have to do with how many you have. It's just how many is in the whole. So we leave it alone. And then I have 1 whole plus 1 whole equals 2 wholes. Well, I'm looking at this. Does this look a little odd to you? Yeah, I have 2 wholes, and then I have 4 pieces out of 4 pieces. What is that? That's a whole, another whole. So I'm going to go ahead and combine that and make 3 wholes. All right, so if Dennis and Cody combine their buckets of blocks, will they have enough to build their castle? If they have 3 buckets, I better put buckets, right? Will they have enough? Now this other number, this random other number we had, 2.5 comes back into play. So do they have enough? Right, they do have enough. So Cody, and again, I always say just write it out so that whoever's looking at your work knows what you're saying. Cody and Dennis, and that is an and sign, by the way. Cody and Dennis have more than enough to build the it's not a sand castle. It's just a castle. I don't know why I want to do a sand castle. I guess I'm thinking it's summer. Let's go play in the sand. And I'm going to put a period. Have I answered the question? I've answered it, but have I any proof? I have this proof, so let's go ahead and put that in our answer. They have 3 buckets when they only need need 2.5 buckets. Have I answered the question? Will they have enough to build their castle? Yeah. Did you guys figure out how much over they have they only needed 2.5. How much extra do they have? Half a bucket. All right, so let's move into our next question. And this one, if you did the leapfrog question with us, I hadn't left this one off and had not finished it, so I wanted to come back because I really liked the leapfrog. And with the leapfrog, what they had to do was they had to jump on 3 lily pads, the frogs, before they got to the island. And what did they have to have in that island to be able to get there? They had to have 1 hole. So, frog number 6 wants to join his friends on the island. His 3 lily pads are 1/4, 1/5, and 10/20. Can he make it? So what do we have to do here? Yep, we got to do the math, right? We need to know, will this equal 1 hole? All right, so this is where normally I and many, many, many other people get confused. I notice 4, 5, and 20, right? They're not the same numbers like our other ones that we used to work with. They're different, so we got to work with that. we have to find what's called a common denominator. Because I know in the past, this was what I used to do. 4 plus 5 plus 20. That is equal 29. Woohoo, I'm done. No, remember, this is talking about how many pieces of the whole. It's not how many you have, so we can't do any math with it. So we are stuck with that. We got to make what's called a common denominator and figure out so that we can know what's really in the numerator.
So in other words, it could be a common whole?
It can be a common whole. Miss Sears doesn't have her mic on, but that's what she's saying. In other words, this could be we need a common whole. So what I do is I personally look at a 4. That's not the biggest number. I look at the 5. Nope. Then I look at the 20. I always go for the biggest number because that will help me find that how much for the whole. I got to then decide what can all 3 of them go into. So if we start with 20 and multiples of 20, can 4 go into 20? Yep. Can 5 go into 20? Yes. So 20 can be the number that we're going to work with. So if we set this up with 20, now I have to relook at my original fractions and figure out what I did to those numbers to get to 20. So I know that I have 4. What am I going to do to 4 to get to 20? And of course, we can only multiply and divide with when we're finding equivalent fractions. So I can multiply 4 by 5 to get to 20. So I'm going to just do a little thing over here. And I'm going to put it in parentheses so we know it's only this one that I'm working with. I know that I'm going to multiply 1/4 by 5 over 5 to help us find an equivalent fraction. So I know 5 times 4 is 20. 5 times 1 is 5. So I'm going to do the same over here, but I'll have to do it kind of little going up ways. What did I do to 5 to get to 20? I multiplied it by 4. Oops. So I'm going to multiply the top, the numerator, by 4. And then we know that our 10 will stay the same since we didn't change the 20. I'd like you to go ahead and finish that addition and then go ahead and answer this with the sentence if he can make it or not based upon our work that we have done.
All right. Sounds good.
Your mic's not.
Coming up. Hopefully you can hear me now. All right. So that was kind of fun. Now I have a really cool story to read with you guys today. And I have one question for you. Do you have any pets at home? Well, I have a cat and a dog, but I also have several pets that are around in our neighborhood. And we kind of have a neighborhood pet that likes to come around and, visit the other little kitty cats. His name is Rocky, but he reminds me of the character in this book. The name of the story is Six Dinner Sid, and it's by Inga Moore, and it is published by Aladdin Paperbacks. And I'm so excited to read it with you today. All right, Sid lived at number 1 Aristotle Street. Looks like a nice neighborhood, kind of in a city neighborhood. I live more out in the country. He also lived at number 2, number 3, number 4, number 5, and number 6. So truly, he lives at a lot of different places, right? How many different places is it? 6 different places, right? Sid lived in 6 houses so that he could have 6 dinners. Kind of smart, I think. Each night he would slip out of number 1, where he might have had chicken, into number 2 for fish. On to number 3 for lamb, liver at number 4, fish again at number 5, ending at number 6 with beef and kidney stew. Those sound like some pretty good meals, I think. Other than the liver, yeah. Since the neighbors did not talk to each other on Aristotle Street, they did not know what Sid was up to. They all believed the cat they fed was theirs and theirs alone. Can you imagine that? Like, I know my neighbor's cat, and I know that it's my neighbor's cat because they've told me before. Sometimes they'll join me over there. So I do talk to my neighbors, but they didn't know. But Sid had to work hard for his dinner. It wasn't easy being 6 people's pets. He had 6 different names to remember and 6 different ways to behave. Wow, I wonder how he had to be different. When he was being Saramooch, Sid put on swanky airs. Swanky, does that mean it's like fancy? Yeah. As Bob, he had a job. That one's kind of rhymes. He was naughty as Mischief, sounds like his name, and silly as Sally. Ooh, that one sounds like his name too. As Sorry, he smooched. Ooh, I'm wondering what that one means. But as Schwartz, he had to act rough and tough. Looks like he's chasing a dog. My cat does that too. I have a German Shepherd and he scares the dog. It's crazy. All this work sometimes wore Sid out. Before he didn't care as long as he had his 6 dinners. And besides, he liked being scratched in 6 different places. You guys have a cat at home? That's exactly where my cat loves to be scratched, in all of those different places. I know the right spots to hit. And sleeping in 6 different beds. And I can tell you that mine likes to sleep in all different kinds of places, in the windowsill, up in the little notches, by the couch, everywhere. In fact, life on Aristotle Street was just perfect for Sid. Until, what do you think's going to happen? One cold, damp day, he caught a very nasty cough. Uh-oh. Then the next thing he knew, he was being taken to the vet. Poor Sid. He was taken not once, not twice, but 6 times. He went with 6 different people in 6 different ways. Wow. So how would you like to have to go to the doctor 6 times? I don't think I would really like that. The vet said Sid's cough wasn't really as nasty as it sounded. But to be on the safe side, he should have a spoonful of medicine. Of course, Sid didn't have just 1 spoonful of medicine. What did he have? He got 6. Oh no, so besides having to have 1 sip of medicine, which sometimes doesn't taste good, you have to have 6. That can't be fun. Now, one black cat doesn't look much like another. But nobody, not even a busy vet, could see the same cat 6 times without becoming a little suspicious. They're kind of wondering what's going on, right? Sure enough, when he checked in his appointment book, the vet found the 6 cats with a cough all lived on Aristotle Street. Coincidence? I think not. So he called the owners at once. And oh dear, Sid was found out. When they discovered what he had been up to, Sid's owners said that he had no business eating so many dinners. Yeah, they were kind of mad. Look at their faces. Ooh. They said in the future they would make sure that he had only 1 dinner a day. Do you see that one little bowl, that measly bowl that he's getting? That's all he's getting if he lives on that street. Let's see what he does. But Sid was a 6 dinner a day cat. He'd gotten used to that, right? So he went to live on number 1 Pythagoras Place. I like the names of these mathematicians. He also went to live at number 2, 3, 4, 5, and 6. You guessed it. Wonder if he's going to have a better luck over there, or will they figure it out too? Unlike Aristotle Street, the people who lived at Pythagoras Place talked to their neighbors, so they knew. So right from the start, everyone knew about Sid's 6 dinners. And because everybody knew, nobody minded. I think that's a really cute story, and it totally reminds me of the cat that I have in our neighborhood, and he does the same thing. He likes to come over and do that with us. All right, so I want to figure out, and we may only have time for one of these, so if I don't get to them, then I want you to try and figure them out on your own. How many dinners did Sid eat in 1 week? What's one way we could figure this out? Well, we could draw 7 different circles, kind of like his plate, correct? 1, 2, 3, 4, 5, 6, 7. And how many could we put in each one? Well, because if this is 7 days a week, this means he had 6 dinners in each of those days. We could do a 6 in each of those days for each of the days of the week. What's another way to write that? If we did write it in like a multiplication or in a mathematical sentence. I was trying not to. We could write it like repeated addition, 6 plus 6 plus 6 plus 6 plus 6. And I think I need one more. 1, 2, 3, 4, 5, 6. I'm going to put it over here. Or we could write it like a mathematical sentence and say it's 6 times 7. All right? Have you figured that out yet? Well, if I figured that out, if I know 6 times 5, I kind of break up my numbers. So 6 times 5 I know, because I can do 5, 10, 15, 20, 25, 30, is going to be 30. I just need to add those additional 2 6s or 12, and I would have 42. All right, I'm going to go ahead and I'll just forward this next slide because I've done the week for you. I want you to figure out how many dinners would Sid have in a month and a year. Can you do it? Challenge on. All right. Miss Gaudette's coming with us, and we're going to get ready for that game that we're going to play. It's kind of related to it.
All right,
excited
guys.
about it.
So we are playing a game that's an oldie but goodie. We're playing a game called Pig.
Kind of like Sid was a pig, right?
Yes.
Eating those 6 dinners.
Yes. So in this game, we're going to have 2 dice, 1 set for Miss Sears and 1 set for myself. Really, you only need 2 dice for this game. And what we do is you roll it and you take that chance and just keep rolling it, and you're adding up your totals as you go. So we have a nice sheet of paper for ourselves to keep our totals. Here's the catch, and this is where we decide, are you going to be a pig or not? And with that one, you can go ahead and roll, but if you hit 1 on any of the 2 die, you get a 0 for that turn.
And you lose your turn, I think. Right?
Yes, well, you're done. You lose or you get a 0 for the turn, and it's the next person's. If you roll snake eyes or 2 1s on the dice, each one has a 1, you lose your whole amount and you go to big fat 0.
Uh-oh.
So you got to decide, how high are you going to go? What your strategy is going to be? Are you going to be a little piggy? Are you going to be very cautious?
And do we have to go to a specific score?
Wait, yes.
Okay.
This one you can do 100. If you wanted to put up 3 die, you could go even bigger. It's your decision. But for this activity we're going to do up to 100.
All right. So as long as I don't roll a 1, I'm not going to lose any points, or possibly if I roll 2 1s, go to a big fat 0.
Yep.
All right.
All right. You want to do it?
I'll try. This doesn't
Don't
bode well
look.
for me. I think yesterday I couldn't remember whether I had to cover paper or whatever. So, but we'll try. I'm just going to close my eyes. Ready? Just tell me
All right,
1, 2,
ready?
3.
1, 2, 3.
What did I have? Boom. She crushed me.
All right, so I get to go first. So I have 8. I'm going to keep going. 8 plus 7 is 15.
So you're kind of keeping a running total. Mentally.
Yes.
Okay.
I'm going to try one more. I'm going to say 11 and 15 is 26. I'm going to stop there.
You're going to stop there?
Yep.
All right.
I don't want to be too much of a piggy.
You don't want to be too much of a piggy. And also, are we just trying to get to like 100?
Yes.
You're a quarter of the way there almost.
Woo-hoo.
All right. Let me do this. Oh, I rolled a 1. So
what does that mean? Mrs. Sears rolled that 1. She lost her turn. She can put 0 right up on her total right now.
I'm not going to put 0. I'm going to go for a better number next time.
All right. So I'm going to roll again. And I got 3 and 6, which is 9. And 6 and 2, which is 8. 8 and 9 is 17.
We're looking for snake eyes.
Seriously?
Nah, just teasing.
All right, what did I have? 17?
See?
All right, 6 and 3 is another 9. So 17 and 9 is 26. I'm going to stop there.
So 26 seems to be your number.
It must be. I am one of those ones where I like to keep my total going, so I'm going to go ahead and do my addition right now.
Okay.
So
do you
I
want
know-
me to go ahead and start rolling while
Sure.
you're doing that? Or, okay, maybe I'll
I have 52
get some better
so far.
rolls going on. I'm going to really work on this. There's that 1 again. I'm going to switch out that die.
You picked those dice. I went ahead and
I'm going to switch them out.
All right, here we go. I have 9. And then
She
I
might
have,
get to 100 before I even get on the board.
I have 9, and then I have 10, so that's 19. And then I have 5, 8, so I have 8 and 19 is 27.
Mm-hmm.
Ah.
You're going to keep going. Oh! What did she roll?
I got a little too piggy there.
But she got
Somebody
a snake eyes, so what does that do to the whole score? We're tied. See?
I got a little too piggy. I just kept going, doing that addition in my head.
It happens, see? And this is, kind of where you say you're going to roll.
Uh-huh.
You got to know when to stop, Sometimes you're on a roll and you got to know when to stop. All right, finally, I have a 6 and a 2. That's 6 plus 2. I think we're adding, right? Mm-hmm. I'm not time using? Mm-mm. Okay. All right, 6 and 2 is 8. I'm going to keep trying. Hopefully that 1 is long behind me. 2 and 2 is 4. 8 and 4 is 12. See, I'm going to try one more. She seemed to have,
What does that mean? 0 again.
Wait. Oh, I just don't get the accumulated score.
Uh-huh.
But I didn't go all the way to 0. I just never had one where I had a score to start off with.
See? She is one of those ones who always makes sure 5 and 11, so that's 16. And then 16 and 7 is 22.
23.
20. Ooh, whoa.
Oh, I don't know. Could I catch you on that?
All right, fine. I won't use the total.
No. I mean, she could probably do that. I think I only have maybe a couple of minutes for my turn anyway. All right, I had a 6 and 5. That's 11. I'm going to keep trying to go so I can get close to that number maybe. Come on. Nothing. Okay. So I had a 6 and a 5, so that was 11, and 10 more is 21. Come on, let's see. Oh. Ones like me. Couldn't I be this lucky and bunko when there's ones? I don't know why the ones like me today.
All right, guys. So today we had a great day. We did, for our teen, we did our number of the day, but then we added in which one does not belong. We hadn't done that since in the spring, so that was fun to see that one.
Yeah.
Then we went ahead and did some adding with like and unlike denominators. Adding and subtracting, sorry. And then we moved into 6 dinner Sid.
That was a cool book.
I've decided I would look like this if I was 6 dinner Sid. But I can't do that.
Yeah, but it led really wonderfully into the whole piggy idea because we got a little greedy ourselves like Sid. And as you see, I ended up with bupkis, nothing, 0, zilch.
23.
All right, well, we want to thank you for joining us today with At Home at APS. And we we'll love to see you again tomorrow and hope you have a great day.
Have a great afternoon, everyone. Bye.